O processo que nós estamos testando é esse processo. Ele envolve um pré-tratamento, e aí passamos, como esperávamos, por uma dificuldade muito longa, uma dificuldade grande na parte de movimentação de sólidos. Não é fácil essa parte de alimentação, de pré-tratamento, mas já superamos toda a parte difícil do pré-tratamento, que envolve um pré-tratamento térmico, ácido, mecânico. Estamos trabalhando com coquetéis de enzimas na hidrólise, trabalhando muito para separar os sólidos depois da hidrólise, e aí a fermentação e destilação. Esse é o processo que nós estamos, onde nós colocamos o nosso conhecimento, onde nós estamos desenvolvendo essa tecnologia com o que nós desenvolvemos na Petrobras com nossos parceiros e com a KL Energy. Eu acredito que esses testes eles devem ser concluídos aí até final de agosto. O que nós estamos mirando, qual é a nossa meta nesse desenvolvimento tecnológico? Né? Nós queremos, com esse bagaço seco oriundo de 1 tonelada de cana, a nossa meta, inclusive nesses testes que nós estamos realizando com a KL Energy, é de 270 litros por tonelada de bagaço seco, né? E uma produção de 36 litros. Para a gente isso já é resultado dos nossos testes. A gente está, por exemplo, utilizando 1/3 da quantidade de enzimas que colocamos como meta. Então, a gente está muito otimista com esse desenvolvimento. Essa unidade de Upton, da KL Energy, que foi adaptada e foi toda comissionada para se produzir com bagaço de cana. Aquilo ali eu não tinha como tirar uma fotografia do etanol armazenado, mas nós já produzimos muito etanol hidratado e anidro. Então eu coloquei ali, nós colocamos umas garrafas de vodka. Aquela terceira, a foto do meio, é a parte de alimentação de bagaço, né? E essa talvez seja uma parte mais, eu diria que o pré-tratamento é um grande desafio para a produção de etanol de segunda geração. E estamos desenvolvendo não só nos laboratórios da KL, continuando com o desenvolvimento tecnológico, mas nos laboratórios nossos e dos nossos parceiros, para que esse processo amadureça muito em breve. O foco desse painel aqui, né, se pergunta se o futuro começou, mas o futuro não chega. Quando ele chega, ele é presente, né? Então, nós estamos sempre sendo desafiados, quem trabalha com tecnologia, com desenvolvimento tecnológico. Então, como é que a gente vê o futuro? As primeiras unidades vão ter um determinado nível de eficiência, de economicidade, mas a segunda e a terceira geração das unidades industriais de produção de etanol de segunda geração, elas terão uma eficiência muito maior, e para isso é necessário mais desenvolvimento tecnológico. Um grande desafio, e isso passa talvez para a viabilidade do etanol de segunda geração, do etanol lignocelulose, é integrar o processo de segunda geração ao processo de primeira geração. Nós já estamos olhando também para esse desafio. Novas enzimas otimizadas, isso sempre vai ser importante quando a gente falar de etanol lignocelulósico, né? Nós temos algum desenvolvimento e acreditamos que é possível, sem cair a produção dos açúcares, a gente ter cana-de-açúcar com uma fração lignocelulósica menor. Isso é possível geneticamente. E o retorno financeiro da segunda, e da terceira e da quarta geração das usinas industriais vai ser bem maior. As primeiras terão uma economicidade, e a segunda, a terceira e a quarta geração, assim como acontece com outras tecnologias, a economicidade deve ser bem maior. Era isso que eu tinha que falar para vocês. Obrigado.
Sim, perfeito. Muito obrigado, João Norberto, pela apresentação e, surpreendentemente, no horário também. Não é? Repito, por favor, vão pensando nas suas perguntas e a gente vai tentar cumprir o horário para ter tempo. I invite now my colleague, Mr. Professor Lynd, and if you want to make a short introduction of yourself, it's okay.
Yes, okay. So thank you very much, Jaime. It's my pleasure to be here and have a chance to share some perspectives on second-generation ethanol. Jaime mentioned I might introduce myself. I actually did my undergraduate thesis on cellulosic ethanol in 1979 and have been working on it ever since then. I'm a professor at Dartmouth and also a co-founder, chief scientific officer, and member of the board of directors of Mascoma Corporation. But I want to talk to you today in a few slides really about the technology. I'd be more than happy, in fact, I'd be delighted to talk to anybody about Mascoma Corporation, but that does not figure prominently in what I'm going to say here. But I would just point out that this is work of several people, including Zach Lasordo, who's at the meeting, really joint between Mascoma and Dartmouth. So let's see if I can make this go forward. Super. So this is the world I come from, the second-generation ethanol world. I mentioned that I've been involved in this for 30 years. I led a project called The Role of Biomass in America's Energy Future, which is the most comprehensive published study of mature cellulosic ethanol technology. I underline the word mature because we were trying to forecast where the technology is going, not just where it is. This occurred in 2009, this report in a special issue of BioFPR. But we did not consider sugarcane in that report because we were doing it for North America. This perspective has been updated recently based on information from Mascoma Corporation, who has spent about 200 person years developing second-generation technology since 2006. I can talk about some aspects of that, not all of them, but I will say that in general, there are really four things, I believe, necessary to make second-generation, to realize the potential of second-generation biofuels. One of them is advanced pretreatment. Another one is consolidated bioprocessing, which is the idea of having the fermenting organisms make all the enzymes you need so that you do not need to add enzymes. This was recently called, actually not that recently anymore, but a few years back, the U.S. Department of Energy and Department of Agriculture issued a roadmap report for bioenergy, and they called consolidated bioprocessing the ultimate low-cost processing strategy. I believe that to be true. One also needs pentose conversion to fully realize the fuel production potential. And finally, careful attention to all integration aspects, including thermal integration. And so this is the world that Brazil is leading and blazing the trail in. And frankly, in my frequent visits to Brazil recently, I have been trying to learn, and I appreciate my many teachers, several of whom are mentioned here. But this spring, we have developed an Aspen model of first-generation ethanol intended to represent best current practice. This entire analysis, including that model, is a work in progress. It is not intended to be presented as the final word, but as you all know, once you have a framework, you can start systematically improving that. And so we're talking at this meeting and elsewhere about further collaboration to validate the first-generation model. But clearly at the intersection of these is the subject of today's presentation. And I'm going to approach that in the context of a very specific question. There are other questions that are relevant. There are other time frames that are relevant. But I'm going to approach second-generation ethanol in the context of what could be achieved at pilot scale in 3 years given a substantial technology development effort. So the scenarios that are examined are 5. Number 1, first-generation ethanol with cogeneration from bagasse. We did not analyze cogeneration of sugar, although that's in the works. or co-production of sugar, I should say. Number two, first generation of ethanol with more electricity made, the idea that you could make yet more electricity from the trash, the cane trash. So the last three include second generation ethanol. The first one is first and second generation ethanol with electricity, but only using the bagasse. The fourth one is first and second generation ethanol with cogeneration of electricity, also using the cane trash. And actually we use, in this model, 50% of the cane trash, thinking the rest needs to be left on the field. People are still doing research on that. And then number five is the same as scenario 4, but we increase the thermal efficiency of the parent plant, the first generation plant, which means you can make more second generation ethanol. Yeah, this works, lovely. So basically it's 80 liters per ton of crushed cane in scenario 1 and 136 kilowatt hours in our analysis for the electricity. If you use cane trash to make electricity, you make considerably more of it. You leave ethanol the same. If you use the bagasse only to make second generation ethanol, you still make a good deal of power, but you make 29% more ethanol. If you use bagasse and trash to make second generation ethanol, and you do not change the first generation process, you still make quite a bit of electricity, a little more than half of here, and now 81% more ethanol. If you also increase the thermal efficiency of first generation, you make just about twice as much ethanol per unit cane, and essentially no electricity, although the plant generates its own electricity. So if we can progress, I'm pressing here. It's all on the wrist. Oh, now we're going to the end. All right, giving away all the secrets. Come you. All right, we did that. We did that. This is the review part of the presentation. We did this. Excellent. Come now. Okay. So in terms of capital and operating cost, here is the operating cost for the first gen and the capital on a per liter basis, reais per liter. Here's the operating and capital per liter for the second scenario where you make lots of electricity. And you can see in general as you go to these second generation scenarios, the operating costs are much lower. And indeed the capital cost per liter is also somewhat lower. The lower OPEX is because more value is derived from the feedstock. The revenue per feedstock ratio is substantially improved. And this would give robustness to price volatility, which was mentioned in the introductory comments. The lower CapEx is because on a per liter ethanol basis, there's less cogeneration capital going on in the lignocellulose second generation scenarios. So you can talk about CapEx, you can talk about OPEX, but how does that translate into the allowable selling price? And there are different assumptions to do this. There we go. But this is the minimum ethanol selling price. You can read some of the fine print. The slides will be available to study. I would be happy to correspond with people. And this is based on a 15% internal rate of return. You could adjust all of these things. We get about 70 reais, or 0.7 reais per liter for scenario 1. Interestingly, according to these assumptions, if you process cane trash, the price for the ethanol is somewhat lower if you convert cane trash to electricity. This is for the bagasse case. I'll explain the blue ones in a minute. This is for the case with cane trash also processed. And this is for the case with the improvements in the parent plant. This seems to get a little more expensive on a selling price basis. But this is for operating 200 days a year. And this was actually mentioned by the first speaker. For cellulosic feedstocks, you could conceivably make better use of your capital and operate year-round because both cane trash and bagasse